In this video, we're going to talk about IFR minimum in-route altitudes. While flying IFR routes, there are a number of minimum altitudes to be familiar with, even a maximum altitude. Each of these minimum altitudes include requirements and/or helpful navigational information built into the value. The altitudes we're going to discuss today are minimum in-route altitude, or the MEA, minimum obstacle clearance altitude, or the MOCA, maximum authorized altitude, or the MAA, minimum crossing altitude, or MCA, and the minimum reception altitude, or the MRA. First, let's start with the minimum in-route altitude. The MEA is the lowest published altitude that meets obstacle clearance requirements and assures acceptable VOR navigation signal coverage. This means that if there is higher terrain, then the MEA will be higher. Or if the further away the route is from a VOR, the higher the MEA will be to ensure a clear line of sight from the station to the aircraft. The MEA will be provided next to the airway line on your IFR in-route chart. Multiple MEAs may be listed with small arrows to denote that depending on the direction you are flying on the route, the MEA is different. So here in the example, this route here on Victor 94, we show that eastbound with this little black arrow here in the middle, we have an MEA of 8,000 feet. And then westbound, we have an MEA of 6,500 feet. Then in between each fix, the MEA changes. Over to the east side of the route, we have an MEA of 10,000 feet, and over towards the west side near the Vortex, we have an MEA of 5,000 feet west of the Totec intersection. A T in the route line before an intersection tells you that there is a change in the MEA. So here on Victor 94, you can see before the intersection that it ends in a T and then begins in a T as we go east or west. Same thing at Chrome intersection, right here in the middle. They both have T's. That tells us that the MEA is changing. When traveling along a route from one MEA to another, a pilot is required to pass the intersection where the change is marked on the chart at or above the first MEA, unless the intersection has a minimum crossing altitude, or MCA, which we're going to talk about later. So if an intersection doesn't have an MCA, but it ends in a T, denoting that it's going to change MEAs as you fly through the intersection, you pass the intersection at or above the first MEA, and then once you pass the fixed intersection, you are expected to climb immediately with a climb gradient of at least 2,000 feet per nautical mile to the next MEA. So if we are flying along Victor 94 eastbound, starting at the Vortex here with this orange aircraft, we will first have to maintain above an MEA of 5,000 feet, as you can see here in red. Once we pass the Totec intersection, the MEA changes to 8,000 feet. Now, if there was no minimum crossing altitude at Totec, we would only need to cross it above the previous MEA of 5,000 feet and then immediately begin our climb to the next MEA of 8,000 feet. But Totec does have an MCA for traveling on Victor 94 eastbound, and it's listed at 5,500 feet and denoted by this flag with an X in it. And again, we'll talk more about MCAs here, but what this means is instead of crossing Totec at the previous MEA of 5,000 and then climbing to 8,000, we have to cross Totec at 5,500 because it has that MCA and then climb to 8,000 feet. So for this example, we would have to cross Totec above at least 5,500 feet and then begin our minimum climb of 200 feet per nautical mile to 8,000 feet. Then we start to reach the intersection of Chrome. Once we reach Chrome, there is no minimum crossing altitude listed. You don't see a flag with an X in it. So that means we only need to cross above the previous MEA, which is 8,000 feet, before, again, immediately beginning a 200 feet per nautical mile climb to the next MEA, which is 10,000 feet. You may also see something called an MEA gap, which tells you that there is an authorized break in signal coverage, and we'll talk about that a little bit later. Next, let's talk about the minimum obstruction clearance altitude, or the MOCA. Sometimes there will be multiple altitudes listed for a route, like this one highlighted here with an asterisk. Altitudes listed below the MEA with an asterisk are called the MOCA, or the minimum obstruction clearance altitude. The MOCA is the lowest altitude on airway segments that guarantees you 1,000 feet of obstacle clearance above the highest obstacle in designated non-mountainous terrain and 2,000 feet of obstacle clearance above the highest obstacle in designated mountainous terrain. The obstacle clearance is only assured on the airway. So if you deviate off course, off the airway, again, the airway is 4 nautical miles wide on each side, there could be an obstacle within less than 1,000 feet of the MOCA if you were in non-mountainous terrain area. Unlike the MEA, the MOCA does not ensure VOR signal coverage along the entire route. The MOCA only guarantees VOR coverage for up to 22 miles from the nearest VOR on the route. So if you want to use VORs for navigation on a route, then you will want to fly at the MEA rather than the MOCA. The MEA is slightly higher and allows you to get your VOR signal along the entire route. For this reason, MOCAs are generally not used as an altitude pilots fly at when using VOR navigation, but more so used as a useful information on the terrain below you or what altitude you could use in an emergency situation. MOCAs are most often used by aircraft equipped with GPS. Here on Victor 94, we have a MOCA of 4,300 feet, which again, it gives us that guarantee of clearance in mountainous or non-mountainous terrain. And then it also only tells us that we have a guaranteed VOR coverage for 22 nautical miles away. So from this VORTAC, 22 nautical miles away from that, we would, or more, we would not be able to ensure VOR coverage at 4,300 feet at the MOCA. Let's look at this another way to visualize an MEA and a MOCA. VORs work by sending out signals from a ground-based system to your aircraft in a straight line of sight path. Therefore, any obstacles blocking that straight line of sight can cause interruptions or complete blockages of the signal. In this first aircraft, the VOR has no problem in sending a direct line of sight signal. Even if there is higher terrain, if the VOR signal has enough strength and your aircraft is at a high enough altitude, the direct line of sight signal can still reach your aircraft. This is what the MEA is essentially ensuring. It is saying that the altitude depicted here is the minimum altitude to clear the terrain and the minimum altitude to get a signal. However, if we are below the MEA, we are not ensured signal coverage even if we are still high enough to clear terrain. So here, this aircraft with the red line going to it from the VOR station, it's high enough to clear that terrain, but there is no straight line of sight path to the VOR station, so we would not be ensured the signal coverage. Even the curvature of the Earth can cause blockage in line of sight signals at far enough distances. The MOCA, on the other hand, ensures you at least 1,000 feet of obstacle clearance in non-mountainous terrain, as we see here, and 2,000 feet of clearance in mountainous terrain. This is only assured on the airway that is 4 nautical miles on each side thick. As previously stated, and unlike the MEA, the MOCA does not ensure VOR signal coverage along the entire route. The MOCA only guarantees VOR coverage for up to 22 miles from the nearest VOR on the route. So here we have the aircraft at MOCA 2 and an aircraft at MOCA 1. With MOCA 2, the aircraft is well within the 22 nautical miles, so we can ensure that we have good VOR coverage. At MOCA 1, the aircraft using MOCA 1, we are just beyond that 22 nautical miles, and you can see that the VOR line of sight is being obstructed by that terrain. So if you want to use VORs for navigation on a route, then you'll want to fly at the MEA rather than the MOCA. The MEA is slightly higher than the MOCA and allows you to get your VOR signal along the entire route and not just within the band of 22 nautical miles away. There may also be a third altitude listed in blue, followed by a G in the altitude stack on your IFR route. This blue altitude with a G means that if you have an IFR approved GPS, you are allowed to use this blue lower MEA. Sometimes this lower GPS altitude will be the only altitude your aircraft flies at on the route due to its performance and ceiling limitations. In this example, we have an MEA of 13,000 feet, a GPS/WAS MEA of 11,000 feet, and a MOCA of 11,000 feet. You may also see an MEA gap, as I mentioned earlier, on your charts. When you see this, it is telling you that this portion of the route cannot ensure VOR signal coverage, and it has been authorized by the FAA. So if traveling along a route with an MEA gap, pilots will want to use alternatives to VOR navigation. Another altitude I want to talk about is the maximum authorized altitude, or the MAA. Not all airways have an MAA, but if there are airspace, traffic, or signal interference limitations, then an airway may have an MAA. The MAA is listed above an airway line on your chart, like we see here at 15,000 feet. The maximum authorized altitude is pretty simple. It is the maximum altitude you are allowed on the route. On this T route we see here, your minimum altitude is the GPS MEA at 2,300 feet on T207 or Tango 207 and 2,100 feet on Tango 204. And your maximum altitude is 15,000 feet on both. This gives you a band of altitudes between the MEA and the MAA to fly on along these T or Tango routes. You may rarely ever fly at the MEA or MAA, but instead fly at an altitude in between in which ATC has assigned to you in order to maintain separation from other aircraft on the airway. And just like with VFR flight, there are also IFR cruising altitudes under the hemispherical rule. With IFR, the hemispherical rule is as follows. When traveling on a magnetic course from 0 to 179 degrees, or easterly, IFR aircraft are required to fly odd thousands of feet MSL, like we see here, 7,000, 9,000, or 11,000 feet, for example, here in the red aircraft. When traveling on magnetic courses from 180 to 359 degrees or westerly courses, IFR aircraft are required to fly at even thousands of feet MSL, as you see here, like 6,000, 8,000, or 10,000. And then in between, at thousands plus 500 feet, we had the VFR aircraft. And this allows separation in all directions between VFR and IFR aircraft. The next altitude I want to talk about is the minimum crossing altitude. We talked about this for a brief moment, so now let's go into some details. If an intersection or fix has an MCA, then the pilot is required to fly the intersection at or above the MCA. If an intersection does not have an MCA, then the pilot is required to pass the intersection at the first MEA on their route before climbing to the second MEA immediately, and again with at least 200 feet per nautical mile climb gradient after they pass the intersection. The minimum crossing altitude, or MCA, is charted when a higher MEA route segment is approached. On a fixed intersection with an MCA, there will be a flag symbol with an X in it, like we see here at Jamie intersection. The MCA will be listed just above the route line, but will be accompanied with an arrow or direction, north, south, east, west, etc. That signifies the direction of flight that the altitude is for. Here, the chart is telling us our minimum crossing altitude is 8,300 feet when eastbound on Victor 536. Additionally, MCAs for the crossing at a fix above a navigational facility will not be printed on top of the route and instead will be found under the navigational facility's information box. You will also see a flag symbol with an X inside of it coming out of the station, like we see here at the PXR VORTAC. Multiple MCAs may be listed in the information box, and each one will be associated with an airway number and a direction. This direction is the direction you are leaving the fix or the navigational facility. So if you are leaving the fix on an airway in the south direction, you would use the MCA listed with an S after it. Sometimes the MCA at a fix or intersection will be higher than the MEA along the route. You are required to cross the fix or intersection at or above the MCA, so you would therefore have to climb before reaching the fix or intersection to at or above the MCA. So here in this example, the MCA at PXR Vortex is 9,400 feet northwestbound of Victor 257 and 8,000 feet northeastbound on Victor 528. So if we are leaving the fix at PXR Vortex on Victor 257 to the northwest, our minimum crossing altitude for above the nav station, so when we cross above the nav station, we have to cross at or above 9,400 when we're traveling to the northwest, again, on Victor 257. And if we are leaving the fix at PXR Vortex on Victor 528 to the northeast, then we follow this MCA, which tells us we have to be at or above 8,000 feet when we cross above the vortex. Remember what I stated earlier. If an intersection has an MCA, then the pilot is required to pass the intersection at or above the MCA. If an intersection does not have an MCA, then the pilot is required to pass the intersection above the first MEA on their route before climbing to the second MEA immediately. Again, with at least 200 feet per nautical mile climb gradient after they pass the intersection. And on top of that, sometimes the MCA at a fix or intersection will be higher than the MEA along the route. You're required to cross the fix or intersection at or above the MCA, so you would therefore have to climb before reaching the fix or intersection to at or above the MCA if you weren't already above it. So what does this look like? For this example, we're going to show two views. So we're going to be traveling eastbound here on this yellow. We highlighted this route in yellow, Victor 536 eastbound. And then below, we're going to show our yellow aircraft and kind of the altitude level that we would have to be at a minimum at along the route. So here, we're starting off with our yellow aircraft at position 1. Our first MEA along this route, going eastbound again, is 4,000 feet. So we want to be at or above 4,000 feet to meet our minimum altitude requirement. Then as we approach Lathe, we see that the route ends in a T. That tells us that there is an MEA change after the Lathe intersection. And there is no flag with an X in it, so that means there's no MCA. So that means it's okay for us to cross Lathe at 4,000 feet. But after Lathe, right, the MEA changes to 6,000. So after Lathe, we need to immediately climb to 6,000 feet at the minimum 200 feet per nautical mile climb gradient. So that's what we do. We climb to 6,000 feet immediately after Lathe to the new MEA that's listed here on our chart of 6,000 feet. And that's what we see at position 3. As we continue on, we start to approach Jamie. But if we look at Jamie, there is there's a flag with an X in it that denotes an MCA. And the MCA is listed for the eastbound route on Victor 536, which is our route. And it says the MCA is 8,300 feet. That means we have to be at a minimum of 8,300 feet by the time we reach Jamie. We have to cross Jamie at that minimum altitude. So that means we have to climb before. So here, position 4, where we're just before Jamie going eastbound, we need to climb to 8,300 feet. So that's what we do here from position 6, where we climb to 6,000. We would just continue on to 8,300 feet to get to that altitude prior to Jamie so we can meet that MCA. Once we pass Jamie, again, we see that there's a T in the route on either side of the intersection on the black line. That tells us there's another MEA change. And if we look, that next MEA change is 10,000 feet. So as soon as we cross Jamie, at or above the MCA of 8,300 feet, we would then start climbing immediately to the next MEA of 10,000 feet. So we would get to 10,000 feet, again climbing at the minimum climb gradient of 200 feet per nautical mile. And now we're at the 10,000 feet MEA for the next portion of the route. And we would continue on through the Manti intersection. And again, there's a T in those lines around Manti, but we don't show it here what the next MEA would be. There's no minimum crossing altitude there, so we can cross Manti at 10,000 feet. But as soon as we cross it, we would want to, again, climb to the next MEA, whatever it is that MEA is. We just can't see it here because it's cut off. Now, alternatively, we could have just planned from the very beginning, back at position 1, to go up to 11,000 feet, and that would have met all these requirements along the way. So that's kind of some of the planning you want to do when traveling along an IFR route, is kind of look at these altitudes, look at these minimum altitudes, and kind of plan ahead what altitude you want to be at. Now, this is also where ATC comes in handy, and they can help you do this along your flight. There is one more altitude we should mention, and that is the minimum reception altitude, or MRA. MRAs are the lowest possible altitude you can receive a crossing radio signal at an intersection. In many cases, an MRA at an intersection will be higher than the MEA along the route prior to that intersection. For example, you may be flying along a Victor airway with an MEA of 7,000 feet MSL and approach an intersection with an MRA of 8,500 feet MSL. This means that if you want to receive the signal of the crossing VOR radial, and therefore both VOR signals, the VOR signal for the radial you're on and the crossing radial at the intersection to check your bearing and identify that intersection, then you need to be at the MRA of 8,500 feet MSL and not the MEA of 7,000 feet. The MRA is denoted by another flag symbol just like the MCA, but instead of an X in the flag, there is an R for reception. Then the MRA will be listed underneath the intersection's name label. Obviously, an MRA does not apply to pilots flying with an IFR certified GPS. You may also be able to get by without using the MRA if you have a DME. Since most intersections list the distance from the VOR station with DME, such that you can know you are at the intersection when your DME matches the distance on the chart. In the example here, we have an MEA of 6,000 feet, but an MRA of 9,000 feet. If we want to get a crossing radio signal to identify our 𝐬𝐿𝐴 intersection, we need to be at that MRA of 9,000 feet. Now, to sort of summarize all these altitudes, you are guaranteed at least 1,000 feet of obstacle clearance in non-mountainous designated areas and 2,000 feet of obstacle clearance in mountainous designated areas on any of the following published altitudes: the maximum allowable altitude, or MAA, the minimum crossing altitude, or MCA, the minimum reception altitude, or MRA, the minimum obstruction clearance altitude, the MOCA, and the minimum in-route altitude, the MEA.